Hello there, I'm Lewis Hammond and welcome to a breakdown of my tank scene, which has two different AI techniques. I've implemented behavior trees for one of the teams and goal-orientated action planning for the second team. In this video I'm going to break down the different elements that make up the AI and then at the end show a few rounds of the AI working all as one unit. Both of the techniques use a number of sensors in order to gather information about the world. The first of which is vision cones. Now the tanks have multiple vision cones with different weights in order to establish information about what it can see. So the blue vision cone here has an incredibly low weight as it's very thin and travels a long distance. Whereas the yellow vision cone will have a very high weight because it's about objects that are close to the tank. Secondly, the tanks use hearing, which is represented by the yellow sphere here. So the tanks have a hearing radii, which then picks up sounds. Sounds are created when something noisy happens in the level, for example, the explosion of a tank shell, which you can see represented here by this little grey dot. The tank will then respond to sounds within its radius and use those as places that it could possibly investigate. I'm now going to break down the implementation of behavior trees. Within the Unity editor, I have a behavior tree editor which you can use to explore the entire tree, but for now I'm going to break down the individual behaviors. So the first behavior in the tree is a find cover behavior. Now this is first in the tree because it's the most important. It may fail most of the time, but we want it to activate every time we need it to. As you can see here, this behavior activates when the agent cannot see an enemy because it doesn't want to lead the enemy to the cover point that's about to hide in. It also does a health query when the health is less than 25. Then there'll be a sequence to find cover points that are in the level, and then an action to evaluate what the best cover point to go to is. And then after that, the tank will physically move to the cover point. Now we have a more generalized flee behavior, so when the tank can be seen and has low health, it still needs to run away from the agent that's chasing it. So as you can see here, it will just go in the opposite direction of the agents. If there was multiple agents here, it would take an average direction of them and run there. And you can actually see in this video that once the agent has escaped the sight of the enemy, it will flee to cover instead. This is because cover points give our agents health. Next we have the attack action, which will check if we can see an enemy. It will determine the best enemy to attack based on a number of factors like distance and the amount of health that the enemy has. It will then check if we can fire the cannon. It will point the cannon at the enemy, and then once the cannon is pointed at the enemy, it will fire a bullet. Then after that we have the flank action, which is a subset of the attack. So if we can see an enemy and we have determined the best enemy to attack, but we can't fire, then we should try and flank the enemy and get directly behind its cannon so that it can't fire at us, but we can fire at it. After this, we have the seek action. So if we can't see an enemy, but either we have recently seen an enemy, we can hear a sound that has been created by an enemy, or a member of our team can see an enemy, more on this in a little bit, we should move to one of those positions, whichever one has been activated. Here the tanks will prioritize their own information first, as it's probably more reliable and they're probably closer to the point. Finally, we have a wander behavior. This is the default behavior at the end of our tree. So if there is nothing else to be activated, we should wander. Now there are two additional behaviors here. The condition can't see enemy and condition team not seen enemy. These are checked every frame that we are in the wander state so that we can immediately interrupt it if we need to, if we've either seen an enemy or a member of our team has seen an enemy. There are two variations of the wander action. There is a patrol cover point wander, which will patrol all of the cover points around the level to try and find an enemy, or a random wander, which will just choose a random point on the nav mesh and wander to there. These both have an equal chance to be picked from the random choice node. I'm now going to move on to the goal-oriented action planner. So my GOAP implementation works by having a set of actions that can set states. It can also set agent beliefs, so beliefs on a specific agent, to create a plan that achieves a goal. A goal here is just a collection of states that we want to get to or achieve. Now, within this implementation, some of the states are set by the agents themselves. For example, if the agent can fire, this is because the results of the actual goal-oriented action planning actions should be deterministic, and we can't create an action that will guarantee that we can fire because there is a cooldown. Now, in my implementation, it's not always possible to have every action succeed. For example, if we have a wander position that's not on the nav mesh, but we always try our best not to abort a plan once we have one, because planning is expensive. So just as with behavior trees, I'm going to break down each of our goals that we have within our planner. The first is going to be fire. So in order to fire, we need to determine an enemy to shoot at. We need to point our cannon at our enemy. Now this may just be a one frame check if the cannon is already pointed at the enemy, or if it's pointed somewhere different, we will wait until the cannon is pointed at the enemy and then we will fire a bullet. Secondly, we have our flee to cover action. So as before, if we cannot be seen by an enemy, which is set by the agent itself rather than as an action, we will determine a position that we can wander to that is in cover, and then we can flee to that position. Now we want to flee to this position if we can't be seen by an enemy, because our cover points will refill our health, and if we lead an enemy there, we kind of negate the reason for going to the cover point in the first place. Now if we can't be seen by an enemy, which again is an agent state, we will just try and flee away as before, taking an average of all the agent positions and going in the opposite direction from them. We also have a flank state, so this will try and get round the back of the enemy. Then we have seek as before, and we can determine seek from a number of actions. We can either do it from our hearing, our vision, or from our team information, as in the behavior trees implementation. The difference with the goal-oriented action planner is that all of these actions are disconnected, so it doesn't matter which one we achieve. And then finally we have the default wander state if we cannot achieve any of those goals. Now the tanks within this level do work together as a team. So team members will use their vision in order to update a team blackboard. They will update if they can currently see an enemy, or if they have the last known position of an enemy, and write that to the blackboard. Now the blackboard has an arbiter that will only let agents write information that they're more confident in. For example, if the vision cone from one agent has an enemy in a higher weighted area than its teammate, it will take this information, or more recent information. So if a position was updated 30 seconds ago and we have an update from 15 seconds ago, we will choose the 15 seconds ago update. And we saw this before both in the behavior trees and the goal-oriented action planning that will take in these scene positions if it doesn't have any information to seek on itself. And both of these implementations, goal-oriented action planning and behavior trees, will interrupt a wander in order to act on team information. Thank you very much for watching this breakdown of my AI implementations. I'm now going to leave in 3 rounds of the AI playing against each other just so you can observe what kind of thing happens when all of these behaviors are combined together. Thank you very much and goodbye.